So we start with the problem, the first problem. Problem 1. Suppose T is a linear transformation from R3 to R2. So T is a function from R3 to R2 defined by T of x, y, z equal to x plus y, comma y minus z. Now what is the matrix of T corresponding to the basis? Okay, in the domain basis we can call B, script B. The basis is 1 1 1 and 1 comma minus 1 comma 0 comma 0 1 0. So this is a basis in R3, and if you take a basis in codomain in R2, just take 1 comma 1 and then 1 comma 0. Okay, so what is the matrix of T with respect to these two bases? So the first option is minus 2 0 1 1 1 minus 1, and then B should be 0 minus 1 1 2 1 0. Then third option, column wise, 2 1 0 minus 1 1 1, and then the last option 0 2 minus 1 1 1 0. So actually the codomain coordinate dimension is 2, the domain dimension is 3, therefore the matrix should be 2 by 3 matrix. Okay, so first of all the matrix, so the domain is script B basis, codomain is script B dash. It should be a dimension, codomain dimension 2, domain dimension 3, therefore should be a 2 by 3 matrix. Now how to form this matrix? You have to find the value for the given basis element. So T of first basis element is 1 comma 1 comma 1. By the definition of this one, you have to add the first two and then subtract last two. Okay, so that is 0 2 comma 0. Now we have to express this is a linear combination of the basis in R2. So simply we can write 0 times 1 comma 1 plus 2 times 1 comma 0, we will get 2 comma 0. Okay, so the next basis element is 1 comma minus 1 comma 0. So the sum should be here 0, and here the subtraction is minus 1. So we can write this as combination of this one. So minus 1 times 1 comma 1 plus 1 times 1 comma 0. If you multiply inside, if you simplify the first coordinate here minus 1, there plus 1, we get 0, and then minus 1 0 we get. So we get this can be written as minus 1 times 1 comma 1 times 1 comma 0, you will get 0 comma minus 1. And then the last basis element T of 0 comma 1 comma 0 should be 1 comma 1, because sum of first row, last of subtraction of last two. It should be written as 1 times 1 comma 1 plus 0 times 1 comma 0. Okay, so should be, you can pick this element, you have to write as a first row. So therefore the matrix should be 0 minus 1 1, and then the second one is 2 1 0, because the matrix should be 2 by 3 matrix. Therefore option B is the correct. Now the second question, suppose the characteristic polynomial of M is, so the characteristic polynomial equation of a matrix m is or be some lambda square minus lambda minus 1 equal to 0, then which of the following is true? First option, m inverse does not exist. And then second option, m inverse exists but cannot be determined from the given data, but cannot be determined from the data. Third option is m inverse should be m plus identity matrix, and then fourth option should be m inverse equal to m minus identity matrix. So it is clear, right? So simple. So and we know that the constant term is nothing but the product of the eigenvalues, because the eigenvalues are nothing but the roots of the characteristic polynomial. So the coefficient of lambda is the sum of the eigenvalues, the constant term is the product of the eigenvalues. Since the determinant is minus 1, therefore the product is non-zero, therefore inverse exists. And by Cayley-Hamilton theorem it satisfies characteristic polynomial, therefore m square minus m minus identity equal to 0. Now you can take m outside and then take I that side, therefore we get m minus I equal to I. First you take I that side, we get m square minus m, from that you can take m outside. Now multiply m inverse of both sides, because m inverse exists because the determinant is non-zero, therefore multiply m inverse of this side, therefore m is equal to m minus I. So this is the answer. Okay, now next question from real analysis. Third question, suppose the continuous function defined by continuous function from R2 to R defined by f of x equal to x square plus 1 whole power 2003 is 1 1 on 2 or not. So the first option is on 2 but not 1 1. Second option, 1 1 but not on 2. 1 1 but not on 2. And then third option, both 1 1 on 2. Both 1 1 on 2. And the last one is neither 1 1 nor on 2. Neither 1 to 1 function nor on 2 function. So clearly this is a onto function. Why this? Okay, this is why this is onto or not. Okay, we will check. No, it's not onto. Actually, it's neither 1 1 nor onto, because if you take f of minus 1 should be 2 power 2003, because minus 1 square is plus 1, 1 plus 1 2 we get. Similarly, f of 1 also 2 power 2003. The elements are different, the images are same, therefore f is not 1 to 1. Different element matches to same element. Okay, therefore it's not 1 1. And look at this one, x square plus 1. X square is a positive number, 1 is also a positive number, therefore the sum is greater than or equal to, even you can say strictly greater than 0. If you multiply these, a positive number multiplied 2003 times, still is positive. Therefore, the image should contains only the positive terms. Therefore, this is not onto because the codomain contains negative term also. So, therefore, none of the elements maps to the negative real numbers. Therefore, if we pick the negative real numbers in the codomain, we cannot find the pre-image. So, therefore, this function is not onto because range contains only the positive numbers. Since f of x all x, f of x is positive, therefore, f is not onto. F is not onto. So, therefore, neither 1 1 nor onto is the correct answer. Okay. Now, the next question, orthogonal trajectories of the family of curve. The orthogonal trajectories. Orthogonal trajectories of x square plus y square should be equal to 2 times cx. The series arbitrary constant is first option x square plus y square times y dash equal to 2xy. Then b x square minus y square times y dash equal to 2xy. Then third option is y square minus x square times y dash equal to xy. And then the last option y square minus x square times y dash equal to 2xy. So, which of the following is orthogonal trajectory family for this one? So, you have to differentiate the given equation with respect to x. So, if you differentiate this one, so the given equation is x square plus y square equal to 2 times cx. So, if you differentiate with respect to x, we get 2x plus if you differentiate y square, we get 2y. Again, if you differentiate y, we get y dash, and this side is we get just 2 times c. Okay. Now, if we cancel these two, because all the term contains 2, therefore we have a, otherwise if you want you can replace this 2c by x square plus y square by x, x square plus y square by x. Okay, anyway, first you write y dash equal to, and then you have to replace y dash by 1 by minus 1 by y square. So, first you cancel 2, therefore we get okay. So, x plus y into y dash equal to c, therefore y dash equal to c minus x by y. Okay. So, this is y dash. Now, you have to replace y dash by minus 1 by y dash, therefore this side is 1 by minus 1 by y dash equal to c minus x by y. Now, you have to replace the c value. Anyway, from this we can write what is y dash. So, just to cross multiply y dash, we get minus or c minus x, sorry, y by c minus x.
Sir, can we substitute the c value in the initial given equation?
Yeah, finally you have to cancel that c. So, anyway, you can substitute either in the starting itself or here.
So then I get y square minus x square is equal to 2x, 2y, y square minus x square is equal to 2xy dy by dx.
So, what is the correct answer now?
Dy by dx is with the 2xy.
So, what is the answer? You are saying answer or? Okay, we will check. So, just to cross multiply, we get y by x minus c. Okay. So, this is y dash. Correct. Now, substitute the values of c here. This cross multiply, we have x minus c into y dash equal to y. Correct. Now, x minus what is c? is x square plus y square by 2x. This is C into y dash equal to y. So just cross multiply 2x, we get 2x square minus x square into you can take this thing equal to 2xy, right? Yeah. So but in the option what they given, I think none of the answer is right? Where we did mistake? Maybe
Sir, B is right, no, sir?
B x square. Okay, maybe what is the wrong in that in our option? Okay, maybe x square minus y square into y
So
dash.
x minus C whole y dash, no, sir? Y dash belongs to 2x square also, sir, here.
Sorry, where? So
So we wrote x minus C into y dash, no, sir?
yeah,
Next step, sir.
yeah,
And on the left side,
yeah, it's
this
common for y. Yeah,
two
thank.
x-
Yeah. This
yes,
y
sir.
dash is common for this one. So yeah, now it's correct. Now we'll get x square cancel. We have x square minus y square into y dash equal to 2xy, right? So therefore option B is the correct. Okay. Now the next question. So the number of groups of order n up to isomorphism, how many groups we have? So this is simple, we have only finitely many groups up to isomorphism. Okay, so in my notes also I give the formula is something n power n log n something. Okay, so you can pick that formula. So how many groups are there of order n up to isomorphism? We have only finitely many subgroups, so finitely many groups of order n. Given any n, so up to isomorphism we have only finitely many subgroups, so finitely many groups. So I wrote the formula in my own notes also. I think something n power n into log of something to base 2n, I think so. I think at the most this many groups are there of order n. Okay, so just confirm, check this formula. So therefore I leave that question. Okay, so they ask question is the number of groups of order n up to isomorphism, finitely many, infinitely many, all the things. So answer is finitely many, only finitely many subgroups are there. Okay, the next question, I think fourth one, fifth one. So maybe sometimes we can work this one. So consider the matrix M. So you fix one matrix M is a 3 by 3 matrix. There should be 1 0 minus 1 0 1 0 1 1 minus 1. Okay, and we define the new set S suffix M. So what the matrix is? This collection of all matrix A. This matrix commute with this M. So that is A times M equal to M times A. So we collect all the matrix, all 3 by 3 matrix is satisfied the commutative property with this particular M, and then this form is subspace. Then question is what is the dimension of this SM? This is a vector space over R. What is the dimension? So the first option is 0, second option is 1, third option is 2, and then 3. Okay, so there are
So R is a space over what, sir?
means what?
M matrix M, sir, is a space,
No.
vector space over R, sir.
Yeah, it's a vector. This SM is a vector space over R. Entries are all R. I fix one matrix M. We fix one matrix M. but here we define the new vector space Sm. We are collecting all the matrix A. We satisfy the commutative property with that matrix. We can easily prove that this is a subspace. Okay, 0 matrix always commutative property satisfied. Therefore, 0 belongs to this Sm. And then if you take any two matrix, the sum also satisfied. Therefore, it's clear to show that this is a vector space. Okay, this is actually subspace of set of all m by n matrix. But if you look at this is a vector space over R. Now, what is the dimension? Okay. So you have to pick some arbitrary matrix A, B, A. So we take A1, B1, C1, A2, B2, C2, A3, B3, C3. Suppose if you take some arbitrary matrix A. Now multiply with this m. What is this m? You have to multiply. So 1, 0, minus 1, 0, 1, 0, 1, 1, minus 1. So similarly, you have to multiply first m, and then the general matrix A, that is A1, B1, C1, A2, B2, C2, A3, B3, C3. So here totally we have 9 unknowns in the matrix A, that is A1, B1, C1, etc. So you have to reduce that matrix, the unknowns. So if you product these, the first entry should be A1 plus C1. The second entry should be B1 plus C1. The last one minus A1 minus C1. Okay. So this is the matrix from this side. Now the right hand side, if you multiply these, we get A1 minus A3. And here B2 minus B3. And then C1 minus C3. Now again, so what is the next equation? If you multiply these, we get A2 plus C2, and here B2 plus C2, and here minus A2 minus C2. Here if you multiply with this, we have just A2, just B2, just C2, right? Therefore, okay, anyway we can come now last equation. Now if you multiply this matrix, we get A3 plus C3, and then B3 plus C3, and then minus A3 minus C3. Now if you multiply here, we get A1 plus A2 minus A3, and here B1 plus B2 minus B3, C1 plus C2 minus C3. So this matrix should be equal. Now we can compare the coefficient. Now look at this one. So this entry should be equal to this. A plus C2 equal to A2. That means what? C2 should be 0. That is only possible. C2 should be 0. Now similarly look at the second this coordinate. You compare this one. C2 should be 0. So anyway, in this entire thing, C2 should be 0. We get C2 should be 0. But if you look at the last one, what will you get? A2 equal to C2. Therefore A2 should be 0. Okay. Now any other thing we can cancel or anything. Okay. Now you look at compare the first equation, first coordinate. A1 plus C1 equal to A1 minus A3. Therefore A1 we can cancel A1. We get C1 should be equal to minus of A3. Okay. Again, if we take the last one, we can cancel. Okay. I did. No, I think okay, sorry, this is actually B1, right? So because this is B1, therefore this should be B1. Now if you compare this one, second one, B1 cancel, we get C1 equal to B3. C1 equal to minus B3. Okay, similarly if you cancel the again I think this, yeah, this is minus C1 minus A1 minus C1. Okay, so what is minus A1 minus C1? If you compare the third coordinate, it should be equal to C1 minus C3. So if possible, anyway, we can take 2 times. So therefore minus A1 minus 2 times C1 equal to anyway we can multiply minus, we get anyway. So see, we get this one. So any other thing we can cancel. Okay, so far in the matrix, so what are things? So now we get A1 B1 C1 A2 B2 C2. Now C2 is 0, A2 is 0. Okay, and A1 B1 C1 is minus A3, and here we start with A3, right? A3 B3 C3, here A3 and this should be minus A3, and yeah, C1 should be this one, and C1 should also B3. Okay, therefore what is B3? So this should be minus A3, therefore B3 should be A3. So this is B3, that should be A3, right? Because A3 B3 C3, but B3 is nothing but C3. And then what are the remaining things? So now timing we don't know A1, so fix A1, and then this is B1, and this is A2 is 0, and then remaining things B2 is there, and then B3, sorry, C3 is there. Now so far we have only 1 2 3 4 5 unknowns. We have to replace now. Now substitute C1. So now again C1 is minus A3, therefore minus A1 minus minus plus 2 times A3, that should be minus C3. So therefore C3 is nothing but A1 minus 2 times A3. So now replace C3 in terms of other entries. Therefore C3 can be written as A1 minus 2 times A3. Okay, now what about you try to reduce this B1 B2. Okay, okay, if you compare this coordinate, this and this, we'll get B3 plus C3 should be equal to B1 plus B2 minus B3. Okay, so anyway we can take this B3 to that side. We have 2 times B3 C3 value just now we found, right? Okay, and then what is B3? B3 is A3. So okay, anyway we can write this equal to B1 plus B2 minus C3. Okay, but minus C3 is this term. Okay, sorry, actually what is B3? B3 is A3, right? Therefore 2 times A3, maybe can take the C3. So C3 is minus plus A1 minus 2 times A3 equal to B1 plus B2. We can cancel this B3, therefore B1 plus B2 should be A1. B1 plus B2 should be A1. So therefore we can replace B2 equal to A1 minus B1. So therefore this B2 can be replaced by A1 minus B1. So I think almost we did all the things. So now how many unknowns we have? Only 3. So one is A1, B1 and then A3. So we have only 3 unknowns. Therefore the dimension is 3. I think yeah, I think we reduce all the variables. So therefore the dimension of this one is 3. So only this type of matrix commute with M. So which type of matrix? Like this. So this is actually our A. So only this type of matrix will commute with this matrix M. Therefore here the number of unknowns is 3. Therefore the dimension of the subspace is 3, vector space. Okay. Okay, next question. Then so up to isomorphism, the number of abelian groups of order 10 power 5. So I think this is sixth question, or yeah. So sixth question. Up to isomorphism, comma, the number of abelian groups, the number of abelian groups of order 10 power 5 is, so first option is 2, second option is 5, third option is 7, fourth option is 49. So what is the answer?
49, sir.
Yeah, it should be 49. Why? First you have to write this should be prime power, therefore 2 power 5 into 5 power 5, and the formula is the partition of 5 into partition of 5, partition of 5 into partition of 5. So partition of 5 means how many times, how many ways we can write this 5. So we can write 5 and then 4 plus 1 and then 3 plus 2 and then 2 plus 2 plus 1, 2 plus 1 plus 1 plus 1, and then everything is 1, and then what is the other possible? 2 2 1 1 2 3 4 5 6. I think I missed one. What is that? 5 4 plus 1 or 1 plus 4, anything, 3 plus 2. What I missed? Did I miss anything?
3 plus 1 plus 1.
Yeah, 3. Yeah, very good. Yeah, thank you. So totally we have a 7. So therefore this is 7 into 7. Therefore we have 49. So this is only for this formula only for abelian groups. Up to isomorphism, how many abelian groups of order this one? First you have to write the prime powers, and then take the partition of the powers, and then take the product. So that is the thing. Okay. So the next question. So what is the dimension of the set of a symmetric matrix? Seventh question. The dimension of the vector space of all 3 by 3 symmetric matrix. Symmetric matrices is, so the first option is 3, second option is 9, and then third option is 6, last option is 4. So what is the answer?
4, sir.
Summation n, that is n into n plus 1 by 2. So n is 3, therefore 4 by 2 we can do, therefore 6. Okay, so 6 is the answer. Okay, so next question. So suppose A is a non-zero matrix. Let A be a non-zero matrix, non-zero upper triangular matrix. Okay, so should be upper triangular, non-zero upper triangular matrix. Upper triangular matrix, all of whose eigenvalues, all of whose actually the diagonal entries, eigenvalues are 0. Eigenvalues of this one are eigenvalues are 0. Then what can you say about the matrix I plus E? So the first option is invertible. This I plus A is invertible. And then second option is singular. Singular means what? Not invertible, we say singular. Idempotent. So idempotent means what? The square is itself. And then the last option is nilpotent. So nilpotent means what? The power of some power should be 0. That is A power k equal to 0, then A is nilpotent matrix. Now what is the answer? So what is, now we are talking about
Invertible, sir.
Yeah, should be invertible, because the matrix is given that upper triangular matrix, therefore below the diagonals are 0, and so the in this case the only the diagonal elements are eigenvalues, and it is given that eigenvalues are 0, therefore diagonal elements are also 0, and there is some non-zero element in the above the diagonal. So this is matrix A. Suppose if you add I, so I is nothing but identity matrix, therefore we get 1 1 1 and only on the diagonals, and this is 0, and so here some non-zero entries. Now again here the eigenvalues are just 1 1 1 1. Okay, so therefore all the eigenvalues are 1 1 1. If you take the product, it should be non-zero, so therefore it is invertible. So this I plus A is invertible because all the eigenvalues of I plus A are 1 1 1, that is non-zero, that's why is 1. Okay, now the next one. Suppose ninth question, let G be a cyclic group. Let G be a cyclic group of order 6. Then the number of elements of G, then the number of elements G in G such that G should be generate this small g is, so the first option is 5, second option is 3, third option is 4, last option is 2. So what is the answer? Actually they are asking number of generators, should be pi of 6. The number of generators of a cyclic group is pi of n. So here R is 6, therefore pi of 6. So pi of 6 can be written as 2 into 3. And if this GCD for 2 and 3 is 1, therefore we can split into pi of 2 into pi of 3. Okay. And pi of prime is p minus 1, therefore pi of 2 is 2 minus 1 is 1 into pi of 3 is 2, therefore 1 into 2 is 2. Therefore there are only 2 generators in the cyclic group of order 6. Okay. Now next question, number of elements of order 5 in the symmetric group S5. Okay, number of elements of order 5 in the symmetry group on 5 symbol S5 is, so how many in S5? Only 5 cycles. So 5, second option is 20, third option is 24, last option is 12. So how many 5 cycles are there? What is the formula for general R cycles? N factorial by R into n minus R factorial. This many R cycle we have. So substitute n equal to 5, therefore 5 factorial by 5 into 5 minus 5 factorial, that is 0 factorial, we have a 4 factorial. So what is the 4 factorial is 24, right? We can cancel 5, therefore we get 1 into 4, 2 into 6 into 4, 24. Okay. Because here only 5 cycles, because S5 it have only 5 symbols. So the next question, what is the order of the element? The order of the element 2, 2, order pair 2, 2 in the Cartesian product of group Z4 cross Z6 is, so first option is 2, 6, 4 and then 12. So what is the answer? So usually what is the order of ordered pair? If you take any ordered pair, so what is the order of any ordered pair? Is should be LCM of order of the first element and then order of second element in the corresponding groups. So order of 2 in Z4 is 2, because we can add 2 times 2, that is 4. 4 is nothing but 0. So therefore order of the ordered pair 2, 2 is LCM of order of the first element 2 in Z4 is 2. And what is the order of 2 in Z6? We can add 2 3 times, then only we get 0, because 2 plus 2 plus 2 6, 6 is 0. So this is G series 1, therefore LCM should be product, therefore should be 6. Therefore 6 is the order of this element. Okay. Now the next question. One. Suppose A is a 3 by 3 matrix. A is a 3 by 3 matrix whose eigenvalues are 1 minus 1 0. Okay, the eigenvalues of A are 1 minus 1 0. So then what is the determinant of I plus A power 100 is what? So first option 6, second option is 4, third option is 9, fourth option is 100. So what is the determinant? What is the answer?
4, sir.
4. Okay, we will check. So this is 3 by 3 matrix. So the eigenvalues of A are given that 1 minus 1 0. So what is the eigenvalues of A power 100? Just to raise the power 100. So we get 1. 100 is a even number. Again we get 1 0. So what is the eigenvalues of A plus I plus A power 100? Just to add 1 1 1. Therefore we get 2 2 1. So determination is the product of the eigenvalues. If you take the product, you will get 4. Therefore answer is 4. Yeah. Now the next question. 13. Okay. Suppose G is a group of order 30. So simply I can write order of G is 30. Okay. And A, B are normal subgroup. So A comma B is a normal subgroup of G, or normal subgroups. and the order of A should be 2 and then order of B is 5. The number of elements in A is 2, the number of elements in B is 5. Then what is the order of G by the product AB? What is the order of this group, quotient group? So the first option 10, second option is 3, third option is 2, the last option is 5. So what is the answer? So first of all you got to find what is the order of AB. So what is the order of AB? You know the formula. So the order of H intersection K, order of HK equal to order of H into order of K by order of H intersection K. So this is the formula. So this is the order of product of two subgroups. Okay, even if you take the normal subgroup. Now here, what is the intersection? So since the GCD between okay, now if you look at what is A intersection B, actually this A intersection B contains only identity element. Suppose we pick some element X in this A intersection B, X should be in A and X should be in B because it's in intersection. Since X is an element of order of A, in A, therefore order of this element should devise the order of the group. It's the usual one. And here X is also a member of B, therefore order of X should be divides order of B. But order of A is 2. Since order of X divides 2, therefore what is the possible for order of X? Either 1 or 2. And since this is 5 and 5 is a prime number, again what is the possible order of X is either 1 or 5. So cannot be 2 and 5 both at the same time. Therefore only possible is 1. Therefore order of X is 1, therefore X should be identity element. The only possible is identity element. So therefore the intersection contains only trivial element, therefore order of the intersection is 1. Therefore first of all, what is the order of AB? Is order of A into order of B, because A intersection B is 1. Okay, anyway, if you write the formula, I get this one. So therefore this is 2 into 5 by 1, therefore this is 10. Now what is the order of G by AB? Is a finite group, therefore we can directly write order of G by order of AB, or cardinality or order. Okay, we can use any notation, both are same. So it's given that this is actually 10, right? Sorry, 30. Group order is 30, the product order is 10, therefore totally 3. 30 by 10 is 3. Therefore answer should be B. Okay. Now next question, 14th. Suppose M and M are co-prime natural number. So that means what? Co-prime means GCD should be 1. Suppose we have two natural number M and N, GCD is 1. Suppose we define some map phi from set of all integers to Zn or Zm cross Zn, the Cartesian product of the two. How we define? Pi of, if you take any x, goes to x bar comma x bar. So what do you mean by this x bar? Actually we have to take modulo m to this number, and then this x bar is modulo n. Okay, so that is the thing. In this case, what is this is a homomorphism. Okay, so this is a group homomorphism. So what is the kernel? Every homomorphism have a kernel. So what is the kernel of this one? So the first option is MZ, and then should be MNZ. So that is multiples of Mn, or NZ, or Z. Okay, that is what is the definition of kernel. So we have to collect the elements which maps to 0, 0. So 0 means what? In the first coordinate 0 means should be multiple of m. The second coordinate 0 means what? Should be multiple of n. Okay, so the only possible is should be multiple of mn. Okay, so therefore answer is this one. Got it or not? Because by the definition of kernel, set of all elements in Z such that pi of x equal to 0. So pi of x 0 means what? 0 comma 0 or 0 bar comma 0 bar. But what is the definition of pi of x? X bar comma x bar. X bar comma x bar should be 0 comma 0, 0 bar comma 0. So that is x bar is congruent to 0 or x is congruent to 0 modulo m. If you take modulo m should be 0. Similarly, the same x, if you take modulo n, that also 0. The only possible x is should be both the multiple of n and m. Then only if you take the modulo m or n, you will get 0. Okay, otherwise you will not get 0. Okay. Therefore, the kernel should be multiple of both m and n, that is m and z. Okay. Now the next question, 15th question. The integrating factor of the equation. So suppose if the integrating factor if of the equation x power 7 y square x power 7 into y square plus 3 times y into dx plus 3x power 8 y minus x into dy equal to 0 is x power m into y power n. It is given that the integrating factor is x power m y power n. Then what is the value of m and n? Okay, so that is a question. Then m equal, so for the first option m is minus 7 and n is 1. The second option m is 1, n is minus 7. The third option is both n and m are 0. The last option both m and n should be 1. Now what is the integrating factor? So what? So here m, what is m? So this is anyway, this is not exact equation. Therefore m is x power 7 into y square plus 3 times y. And what is dou m by dou y? It should be 2 times y x power 7 plus 3. And what is n? N is 3 x power 8 times y minus x. If we differentiate this partially with respect to x, we get what? 8 times 24 into x power 7 into y minus 1. Now so which one you can take? Which formula? Dou n by dou x minus dou m by dou y. So if you subtract, what you will get? This minus this. Both anyway, both the same term. We have 22y x power 7 and this minus this minus 4. So we have to cancel something. Okay, I think we cannot use even. Okay, so otherwise we can change some other possible thing. So can anyone guess what is that? What is the method we can do is for this one? Which formula you have to use?
So there is one formula, no sir. X power a y power b into my dx plus nx dy.
Yeah, x power a. Is it?
Yes sir.
No, I said only 4 type of right. So maybe is a homogeneous, then we can say. Otherwise, some function of xy into y into dx plus function of xy into x into dy, then we can write 1 by mx plus n, 1 by mx minus ny is integrating factor, right? So otherwise there is simple. Okay, then what your guess actually? So otherwise we know that this is an suppose assume that x power m y power n is an integrating factor. If you multiply these, that equation becomes exact, right? And then you can compare this one. Got it or not? So suppose assume that x power m y power m is exact, so integrating factor. So that means what, if you multiply with this x power m y power m to this entire equation, that the equation becomes exact. That is the meaning of, that is the definition of exact. So if you multiply this x power m y power n to this equation, so what is the equation? X power 7 into y square minus plus 3 times y into dx plus x power m y power n into this x 3 times x cube x power 8y minus x into dy equal to 0. Now this equation becomes exact. Maybe we can call m dash. M dash is x power okay, if you multiply this x power m one side, therefore x power m plus 7 into y power n plus 2 plus 3 times x power m y power n plus 1. This is n dash. So what is n dash? 3 x power m plus 8 y power n plus 1 minus x power n m plus 1 y power n. So now this should be exact, therefore dou m by dou y should be equal to dou n dash. So if we differentiate partially with respect to this, we have n plus 2 times x power m plus 7 into y power n plus 1 plus 3 times n plus 1 times x power m into y power n. So this is dou m dash by dou y. Now what is dou n dash by dou x? If you differentiate, this is 3 times m plus 8 x power m plus 7 into y power n plus 1 minus m plus 1 into x power m y power n. These two are equal. So that means what? Now compare the coefficient. So that side we have a n plus 2 in equal to, here we have 3 times m plus 8, and then the second equation we have a 3 times n plus 1 should be equal to minus m plus 1, right? So if you simplify from the first equation, we have a n plus 2 equal to 3m plus 24. So otherwise okay, you can cancel these two, we get 22. So therefore n equal to 3m plus 22, we get one equation. And then from this 3n plus 3 equal to minus m minus 1. Okay, so therefore we have 3n equal to minus m minus 4. Okay, so we have maybe we can take equation and then solve it. Okay, so we have n minus 3m equal to 22, that is the first equation, and then 3n plus m equal to minus 4. So you first you multiply the second equation by
n is 1 sir, m is minus 7 sir.
n is 1, m is minus 7, because 21 plus 21 we have 1. Yeah, that is correct. Otherwise you can just solve this, you will get. So n equal to 1, m is minus 7. So the first option, n is 1, m is minus 7. So this is simple. Okay. So the next problem. Okay, 16th. So 16th problem. So the so P is a 3 by 3 matrix. So already we solved the problem, this type of problems. Eigenvalues. The eigenvalues are 1, minus 2 and then 3. Then which of the following is true? So the first option, P inverse should be 1 by 6 times 5i plus 2p minus p square. And then the second option, P inverse should be 1 by 6 times 5i minus 2p minus or plus p square. Third option, P inverse equal to 1 by 6 times 5i minus 2p minus p square, and then both are plus. Okay, so P inverse equal to 1 by 6 times 5i plus 2p plus p square. Which one is correct? So you have to, since the characteristic polynomial is x minus 1 into x plus 2 into x minus 3. So this is the characteristic polynomial q of x or something. Okay, so just to multiply and then this one. So if you multiply, we have x square 2x minus x, therefore plus x minus 2 into x minus 3. Okay, and this should be x cube minus 3x square plus x square minus 3x minus 2x plus 6. So therefore x cube minus 2x square minus 5x plus 6. So this is a characteristic polynomial q of x. Therefore q of p should be 0. What is q of p? P cube minus 2p square minus 5p plus 6 times identity equal to 0. And then take 6i to that side and then take p outside and then multiply with p inverse. So finally we get, if you take p outside, we have a p square minus 2p minus 5 identity equal to minus 6i. So we multiply both side by p inverse and then take this minus 1 by 6 to that side. Now it will be 1 by 6 into 5 times I minus minus plus 2p minus p square. So that is the answer. Which one? The first one. Okay. Okay. So the next one, similar problem, finding the integrating factor of this one. So usually they ask one question from integrating. I think in the GATE exam also they are asking integrating factor, right? They are asking anything about integrating factor?
So they asked one question similar to the previous problem, sir.
Oh, okay, okay. So which of the following is not integrating factor? Not integrating factor. So you have to carefully read the question, okay? So it's not an integrating factor of the differential equation x times dy minus y times dx equal to 0. So the first option is 1 by x square. So the second option is 1 by x square plus y square, 1 by xy, and then x by y. Which of the following is not an integrating factor? Anyway, this is not exact equation. Okay, if you differentiate this with respect to y, okay, anyway, this is both are 0, right? Anyway, if you multiply with that one, you will not get a exact equation. So what is that answer? is not an integrating factor is we can replace this. Actually we can replace multiply by y square, we can rewrite as integrating y by x, right? So if you multiply with x square, okay. So how to find that one? Which of the following is not an integrating factor? Look at the first one.
We'll have to multiply with
Mm.
we'll have to multiply the options and check if the equation is exact or not, sir.
Yeah. So if you multiply with 1 by x square, you will get exact format, d of y by x, okay, equal to 0, because it's of the form u by v method. Therefore this is an integrating factor because you will get exact equation. Therefore the first option is not true because that is an integrating factor. Okay, therefore the first one is not true. Now what about others? Other options. Suppose if you multiply with the xy, what will this equation becomes? dy by y minus dx by x, and this is also exact, separate variable, right? Separation variable. Therefore if you multiply this 1 by xy, again this equation becomes exact equation. Therefore this is not a correct option. Got it? Now if you multiply with 1 by x square plus y square, again is this exact or not? So what you will get if you multiply with 1 by x square plus y square, we have x by x square plus y square into dy minus y by x square plus y square into dx equal to 0. So how we can rewrite this one? Why this is an exact? Now take m is x by x square plus y square and n is minus y by x square plus y square. Now if you find dou n by dou y, you will get minus x by 2y by x square plus y square, because we have to keep x is a constant, we have to differentiate y with respect to y, so this will be whole square. Now find dou n by dou x. Now again the same thing you will get x square plus y square whole square. Therefore this is an integrating factor, because if you multiply with this you get a exact equation. Therefore this is an integrating factor, but the question is not integrating factor. So therefore you can easily check that again. If you multiply with this x by y, you will get the first term is x square by y into dy minus just x into dx, because y cancel. Now here m is x square by y and n is minus x. If you differentiate, if you find dou m by dou y, you will get a minus x square by y square, but if you find dou n by dou x, you will get minus 1. These two are not equal. Therefore this is not an integrating factor, because you will not get an exact equation. Therefore this is an integrating factor. Okay, so almost all other problems are similar problem. Okay, same routine problems. Okay, maybe finally we solve only one problem and then we can stop. So 18th problem.
Sir, that theorem, sir.
Yeah, after that I will say. So suppose S equal to is a basis V1, V2, V3, where is a subset of R3. Okay, this is actually basis. What is V1? So V1 is 1 1 1 and V2 is 1 1 0 and V3 is 1 0 0. So this is the basis. Now T is a linear transformation defined from R3 to R2. It is defined only for the basis element. So that is t of v1, the first basis element, goes to 1 comma 0, and then t of the second basis element goes to 2 comma minus 1, and then t of the third basis element goes to 4 comma 3. Now the question is, what is t of this element? 2 comma minus 3 comma 5. What is maps to? So the first option is minus 1 comma 5. The second option is 4 comma 3. Third option is 0 0. The last option is 9 comma 23. So how to solve this one? First you have to rewrite this 2 3 minus 3 5 as a linear combination of this v1 v2 v3, and then use t is a linear transformation. So how to write this as a linear combination? 2 comma minus 3 comma 5 should be some alpha 1 times v1 plus alpha 2 times v2 plus alpha 3 times v3. We have to find alpha 1. So alpha 1 times, what is v1? v1 is 111 plus alpha 2 times v2 is 11 plus alpha 3 into 100. So if you multiply alpha 1 alpha 2 inside in the sum, the first coordinate should be alpha 1 plus alpha 2 plus alpha 3. The second coordinate should be alpha 1 plus alpha 2. The last one alpha 1, just 1, alpha 1 only. Now but this is equal to 2 comma minus 3 comma 5. Now if you compare the coordinates, we get alpha 1 should be 5. Alpha 1 should be 5. Now compare the second one, alpha 1 plus alpha 2 is minus 3. Therefore alpha 2 should be minus 3 minus alpha 1, therefore should be minus 8, because alpha 1 is 5. Now substitute everything in the first coordinate. Therefore alpha 1 plus alpha 2 plus alpha 3 is 2. Therefore alpha 3 equal to 2 minus this sum. Already we know that the sum is minus 3, so therefore plus 3. Therefore should be 5. Therefore should be 5 times okay, now we get alpha value. So therefore here I can write alpha 1 is 5. So if you now apply t both side, okay, because t is we need a t of t. So therefore t of the vector 2 comma minus 3 comma 5 should be, since t is a linear transformation, that the scalars are comes outside. So alpha 1 is 5. Therefore 5 times t of v1. Alpha 2 is minus 8, t of v2, and then 5 times t of v3, and should be 5 times t of v1. So t of v1 maps to 1 0. So therefore should be 1 comma 0 minus 8 times t of v2 goes to 2 comma minus 1, and then 5 times t of v3 maps to 4 comma 3. Okay, so just multiply and then sum. So the first one is 5 minus 16 plus 20, that is the first coordinate, and then second should be 0 plus 8 plus 15, and there should be what, 9 23. 9 comma 23 is the answer, the last one. Okay, so they will ask this type of question. So they define only for basis element, and then they ask for any general element. So first you have to write the general element as a linear combination of the basis element, and then you can find it. Now that Picard's theorem, we can say Picard's theorem, or the fundamental theorem for existence and uniqueness theorem for the first order differential equation. Okay, or simply we can call this a Picard's theorem. Okay, so this theorem says that suppose we have a differential equation, first order differential equation, like dy by dx equal to some function of xy. Okay, with the initial conditions of y dash of some x naught equal to some y naught with some initial condition. Okay, and this f is a actually integral function, integral or Riemann integral. So here we can say as a continuous function, and even though this is actually ellipsis function, so ellipsis on the second coordinate. So that means that f satisfied modulus of f of x comma y1 minus f of x comma y2 should be less than or equal to some constant times modulus of y1 minus y2. Ellipsis on the second variable. So this is a definition for ellipsis on the second variable. If f satisfies this condition for all element, so usually the differential equation they consider only the interval. So defined on the interval they define the x. Okay, so usually all the differential equation they defined only the interval should the domain should be the interval. So okay, so usually they will take interval, not the entire real number. So here x and y are, so x is here varying here, so x varies from this interval. So you suppose the differential equation like consider dy by dx equal to f of x comma y, where f is a ellipsis function that is satisfied this, then it has a unique solution. Maybe we can call this equation number 1, then this one has a unique solution. One has unique solution. So you will get a unique solution using the iteration method. Okay, so how will they start? I think they start y1 is nothing but y naught plus integral f of x comma y naught into dx. Once you find y1, the next go to y2. So y2 is nothing but again they start from y1 plus integral f of x comma y1 into dx and so on. So you will get a sequence of numbers. So if the sequence converges to some y, then this y is the solution. So this is a Picard's theorem. So Picard's theorem says if you take the first order differential equation, the rate is of the form dy by dx equal to function of xy, and this should be that f should be ellipsis function into second variable. Okay, first variable means we got to vary the first variable x1 comma y minus f of x2 comma y should be less than or equal to c times this one, where actually the c is some positive number. Even sometimes they take c is lies between c 0 and 1. Okay, even if we take that one, we say it's a contraction. Okay, but if you take c is positive. So this is a Picard's theorem, and they defined only on the interval. So I think you are asked in the yesterday the dy by dx equal to that problem. Here f of x comma y is a cos of xy. Okay, so dy by dx equal to cos of xy with the initial condition. They give definitely some initial condition x of some x naught equal to some y naught. Now here f of x comma y is cos xy, and we have to check this is a anyway this is a continuous function, and you have to check this is ellipsis or not in the second variable, that is f of x comma y1 minus f of x comma y2. We have to prove is less than or equal to some c times some constant times modulus of y1 minus y2, and this should be equal to modulus of what is this one, cos of xy1 minus cos of xy2. And we know that cos is a uniform thing, therefore you will get this is modulus of xy1 minus xy2. Okay, because modulus of cos x minus cos y should be less than or equal to modulus of x minus y. Therefore you take only that number variable xy1 xy2, and if you take this mod x outside into mod y1 minus y2. So I said already they defined only on the interval. So if you take the interval close interval a comma b, the interval is either positive or negative, even though if you take the modulus of this should be less than or equal to b, because lies in the interval. So maximum b or modulus of b if you take the positive interval. So depending upon this one. So anyway this is less than or equal to some c times y1 minus y2. Here that c is nothing but modulus of b. Okay, So therefore this f is a ellipsis function, the second variable. Therefore by Picard's theorem this equation has a unique solution. Okay. Any doubt? So this condition is very important. The function should be satisfy the inequality this. That is actually ellipsis condition. This condition is called ellipsis condition. This constant is called ellipsis constant. Okay.